Hello dear friends, welcome my channels. Today's discussions is numerical analysis method of iterations. Method of iteration. The roots of fx is equal to 0 are same as the point of intersections of the straight line y is equal to x and y is equal to phi x. So this is the number one property. Second property is the form x is equal to phi x can be chosen in many ways. We choose phi x in such way that phi dash x less than 1. So friends, this is very important, friends. That this is very important, that when phi dash x less than 1, not equals to, friends, less than 1, this is the condition. When phi dash x less than 1, then then iteration process is applicable. Sequence xn converges to the roots alpha. Number C. Number D. The rate of convergence is more if the value of phi dash x is smaller. This method is useful for finding the real roots of an equation given in the form of an infinite. This is the note point, friends. This method is useful of finding the real root of an equation given in the form of an infinite. Type of convergence is linear. So friends, now you can understand that what is the main condition. Main condition is phi dash x, order of phi dash x less mod of phi dash x less than 1. Then we can use iteration method. Our iteration method process is xn n plus 1 is equal to phi xn. This is the iteration process. So friends, let's start to solve a problem. GATE 2021. This problem is very interesting problem, friends. You have to understand. Consider the fixed point iteration xn plus 1 is equal to phi xn with phi x is equal to 3 plus x minus 3 whole cube. X, where x belongs to 2.5 and 3.5, and initial approximation x0 is equal to 3.25. Then the order of convergence is fixed point iteration method is. So friends, whatever I have to find out, order of convergence, fixed point iterations. So friends, how can I solve this? I can solve it easy way, that phi x, whatever it is, phi x, I can write phi x is equal to x, and 3 plus x minus 3 whole cube. 3 plus x minus 3 whole cube is equal to x, and it can be written that implies x is equal to 3. That implies x is equal to 3. So friends, whatever you can say, phi dash r, if it is 0, this value is 0, then x is equal to 3. So phi dash r does not equals to 0 according to the reproduction, according to the iteration process. And phi dash here, phi double dash r equals to, it does not equals to 0. So this is the number 1 phi dash, and this is the number 2 phi double dash r does not equals to 0, and phi dash r equals to 0 equals to 0, phi dash equals to 0, then phi double dash r does not equals to 0. And number 1 condition is order for, how can I find out order of convergence? If phi dash r does not equals to 0, so I don't need to find out phi double dash r, and phi dash r and phi dash double dash r equals to 0, 0, then phi triple dash r does not equals to 0. So this is the order of convergence, triple dash r. Now you see that phi dash x is equal to 3 into x minus 3 whole square. So it is 0 at x is equal to 3, and phi double dash x is equal to 6 into x minus 3. It will be 0 at x equals to 3. Phi double dash 3 is equal to 0. So is equal to 0. So friends, whatever we see, phi triple dash 3 is equal to 6. So it is does not equals to phi triple dash 3 does not equals to 0. So my order of, if phi dash r does not equals to 0, then my order of convergence is 1, and order of convergence is 1. If phi double dash r does not equals to 0, phi dash r equals to 0, then my order of convergence is 2, 3. If we apply Taylor's theorem, gx is equal to gr. I just tell this formula, about this formula, then g dash r into x minus r plus g double dash r x minus r whole square divided by 2 factorial plus g triple dash r divided by 3 factorial x minus r whole cube plus up to infinity. So friends, whatever you see that in here limit n tends to infinity xn n plus 1 minus r and xn n minus r, this is the mod and this is the mod whole cube equals to g triple dash by r divided by 3 factorial, because this portion are order 0, g dash r, g double dash r are 0. So my order of convergence is 3. Now I want to solve second problem, GATE 2004. So friends, iterative scheme, you will see that xn plus 1 is equal to 1 by 5 16 to 12 minus x, where n belongs to n union 0. So xn tends to x and xn plus 1 tends to x, and x equals to gx. X equals to gx equals to 1 by 5 16 minus 12 by x. So friends, gx, or also you can say it is fx, anything. And now let g dash x is equal to 24 divided by x square. Now according to the condition, mod of g dash x less than 1, so for all x belongs to 1.9 to 2.1, this is the value. You can see that g dash x is, take x is equal to 1.9, So my value x1 equals to 1.937. Similarly, x2 equals to x0 is equal to 1.9, x2 is equal to 1.961, and x3 is equal to 1.976 up to and let's see that x9 equals to 1.999. So it is equivalent to 2. So friends, whatever we get, we see, hence it is converged to, hence it is converges. So my questions is asked when it is converge, will converge, this is it will converge to, this is my answer. Now I am going to solve next problem, get 2007. Suppose that x0 is sufficiently close to 3 and which of the following iteration xn plus 1 gxn will converge to the fixed point at x equals to 3. So friends, this problem is very simple problem. Now solutions, it is questions is coming 2000, get 2007. So what is my condition, friends? My condition is phi dash x less than 1 where x is equal to 3. So I will check first equation. So whatever I get, phi dash 3, phi dash x I will write, phi dash x is equal to 6 plus 3 by x square, and it is minus 6 minus 3 x square. Now putting the value 3 in here, so whatever I get, 6 minus 3 divided by 9, and it is cut, and this value is obviously greater than 1. So my this point is not correct. Now I will check second option, that mod of phi dash x equals to 1 by 2 3 plus 2x, and 2 is also in here multiply, so 2 cut, it is not x, it is just 2 cut, and it will, this value is 1 by root 9 is equal to 1 by 3, which is less than 1. So friends, this answer is correct because my condition is, the iteration condition is phi dash x less than 1 by 3. And next, if I will check number C, then phi dash x is equal to 3 divided by x minus 2 whole square minus, and if I will put, then it is this value is greater than 1. So this is not possible, and mod of fx is always greater than, and mod of, and next is in the case of next problem, then we can get x minus 3 by 2 mod. If I will put, then it is, the value is greater than 1. So my number B option is correct. Very simple friends, but whatever is remembering point is, note point is phi dash x, mod of phi dash x less than 1. This is the remembering point, key point of this solution. Next problem is get 2009. So friends, R be a 3 times continuously differentiable. Suppose that the iterates denotes by xn plus phi x. 0 converges to the fixed point xi of phi if order of convergence is 3. then I have to choose phi dash j equals to 0, phi double dash j equals to 0, phi dash j does not equals to 0, phi double dash j equals to 0. I have three options. So friends, you will must see that in my previous problem I have already discussed that you see that phi x is equal to whatever you see friends, phi x is equal to x. So you see that phi dash r equals to 0 and phi dash r equal r and phi double dash r equals to 0, phi triple dash r does not equals to 0, then order of convergence is 3. So friends, in here I have already proved by the Taylor's theorem. You will see that order of convergence is equal to g triple dash r divided by 3 factorial. So friends, easily you can understand whatever you can understand. You can understand solutions. What is the answer? This is a theory and conceptual problem, but one problem is 2 marks. So this answer is correct. This answer is correct as order of convergence is 3. This means phi dash j equals to phi double dash j equals to 0, but phi triple dash j does not equals to 0. So friends, I hope it is clear for you everyone. Now I will discuss Newton-Raphson method. Let x0 be an approximation root of the equations fx is equal to 0, x1 equals to x0 plus h, x1 equals to x0 plus h, if x0 plus h equals to 0. So whatever we get, I get fx0 a f x0 h f dash x0 and h square by 2 factorial f double dash x0. And similarly apply Taylor's theorem. Higher term is neglect because h is very small, that's why h square is also small. So I apply f x0 is equal to h f dash x0 equals to 0. So h is equal to fx minus fx0 divided by f dash x0. So x1 equals to x0 minus fx0 divided by f dash x0. Similarly, x2 equals to fx1 divided by f dash x1. xn equals to xn minus 1 f xn minus 1 f dash xn minus 1. Note, this method is useful in case of large value of f dash x. Large value of f dash x, h will be small, or if f dash x is small, then h will be large. Computation of the root is slowly or not possible. Therefore, this method is not suitable in those cases. So in those cases it is not suitable. Where graph of fx is nearly horizontal while crossing the x-axis. Where graph of fx is nearly horizontal while crossing the x-axis. Newton's formula converges provided x0 and choosing the sufficiently close to the root. Comparing with the iteration method, we get fx phi x is equal to fx divided by f dash x and phi dash x is equal to fx divided by f double dash x divided by f dash x whole square. In the case of iterations, you have to remember phi dash x less than 1. So mod of fx and f double dash x is equal to f dash x whole square. This formula converges rapidly. If x0 is very near to the root alpha, the convergence is of quadratic order, or order of convergence is Newton-Raphson method is 2. So rate of convergence equals to f double dash x alpha divided by 2 f dash alpha. Suppose x0 is not given, then we take two numbers a and b and fb less than 0, and then the root alpha lies between a and b. If fa is nearer to 0, x0 equals to a, and if fa is nearer to 0, then we can choose, otherwise x0 equals to b if fb is nearer to 0. So friends, let's start to solve one problem. This problem is coming GATE 2021. Question number 5. If fx is equal to x to the power 4 plus 2x to the power 4 plus 2x cube minus 11x square minus 12x plus 36 for x belongs to R, the order of convergence of the Newton-Raphson method, while xn plus 1 is equal to xn and minus fxn f dash xn, n greater than equal to 0 and x0 is equal to 2.1 of the equation fx is equal to 0. So I have to find out. So friends, you see that fx is equal to, this problem is very nice problem, fx is equal to x to the power 4 plus 2x cube minus 11x square minus 12x plus 31. Now putting the value, sorry, it is 36. Putting the value f2, so whatever I get 16 plus 16 minus 44 minus 24 plus 36. So this value is 0. And f dash x is equal to 4x cube plus 6x square minus 22x minus 12, and f dash 2 is equal to 32 plus 24 minus 44 minus 12 is equal to 0. So friends, another factor is that f double dash 2 is equal to, you can get 50 does not equals to 0. So double root exists in Newton-Raphson. So friends, if the multiplicity nth, if we know that if nth root of the nth multiple root, I can say multiple root of the Newton-Raphson NR, then the equations is xn plus 1 is equal to xn minus n into fxn divided by f dash xn. So friends, you will see that here n is multiplicity, here n equals to, double root exists, so n equals to 2. So if xn plus 1 equals to xn minus 2 into fxn divided by f dash xn exists, then order of convergence is 2. But in here you see that multiplicity is 1. So my order of convergence is 1 equals to 1. So my answer is 1. This question is very nice questions, and this question is coming GATE 2021. However, if we do not study, we will forget. If you continue your study, then you can solve this problem. Next problem is simple, very simple for problem, friends. Let f such that a comma b and r is the be any function r be any function which is twice differentiable in a comma b, and f dash x and f double dash x denote the second derivatives of the fx respect to x. So alpha is simple root and computative Newton-Raphson's method. Then the method of convergence is obviously number A is correct and all others are wrong. Because how, friends? Because I have already told these options, this formula, friends. Whatever I have told that we know that phi x is equal to x minus fx and f dash x. Similarly, phi dash x is equal to 1 minus fx divided by f dash x whole square, and fx, and it is f dash x also f dash x whole square minus f fx into f double dash x whole square, that implies fx into f double dash x double dash x and f dash x whole square. So friends, this is my and phi x, and now phi x is equal to less than 1. So fx into f double dash x less than f dash x whole square. This is the total formula, friends. I hope I can clear the concept. So my answer is number A. Next problem, friends. Next problem, you will see that fx has a isolated 0 and multiplicity 3 and x equals to xi. The iteration is xn plus 1 equals to xn divided minus 3 into fxn into f dash xn. This is my last problem, and where n equals to 0, 1, 1 converges to xi, then the rate of convergence is. So friends, whatever I have to choose, I have to find out rate of convergence. So friends, I have to find out rate of convergence. So friends, here you see that x n plus 1 equals to xn minus 3 into f xn divided by f dash xn. So now I can write the error is a is equal to epsilon n plus 1 is equal to a plus epsilon n minus f a minus 3 into f a plus epsilon n divided by f dash a plus epsilon. It can be written this way, and epsilon n plus 1 equals to minus f a plus apply Taylor's theorem, epsilon n f dash a plus half into epsilon n whole square f double dash a plus infinity divided by f dash a plus epsilon n f double dash a plus simple I apply, friends, whatever I apply simple Taylor's theorem, half into epsilon n whole square f triple dash a plus up to infinity epsilon n. So friends, it can be written this way: epsilon n 3 into half into f double dash a plus up to infinity, and after that half into f triple dash f double dash a up to infinity, and it can be written this way: epsilon n f double dash n equal to epsilon and epsilon n square, and others term is I remove because as epsilon n is very small term, so it can be written this way: epsilon n. And now you will see that you will consider this as y is equal to mx plus c this way. So it is linear. Now how can I say that f double dash a as f a equals to f dash a equals to 0? Why? Because order of convergence is 3 as a multiplicity of 3. So rate of convergence is a linear. I hope I can clear this concept, and I will discuss in next video regular falsi and fixed point iterations. A lot of topics I will discuss in my next video. Thanks for watching, friends. I hope I can clear the concept.